All right, this is going to be lesson 4.05. This is our exit ticket lesson for triangle congruence with side, 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 side angle side, and hypotenuse leg. We're going to start off with a warm-up. I encourage you to pause the video and see which is the correct answer for representing a line segment AB. Take a moment and answer that question. Okay, so hopefully that was sufficiently long enough for you to select this as your line segment. Remember, this has a straight edge on top with no arrows whatsoever. So the other one over here, this represents a line, just a line. This one represents a ray. This one represents a length of a segment itself. I'm just going to call it length for now. And then this one, of course, is the actual line segment, right? So we want that one as our answer. Today, our objectives are that you shall be able to write a congruence statement for the congruent triangles we work with. And you're going to determine the postulate or the theorem that proves that two triangles are congruent. And we're going to be identifying the included and sides and angles to prepare for the future congruence postulates that we'll be working with. Specifically, we're going to review triangles and congruent parts. We're going to learn about included sides and angles. We're going to practice problems. We're going to talk about those three congruence postulates and or theorems, practice problems related directly to that, and then you have your exit ticket. So let's go ahead and get started with triangles. So for triangles, we want to make sure that we can identify what it is, right? We know that tri means three, the prefix of the word triangle. Three angles, right? So there's three sides and three angles. And specifically, we have triangle ABC there on the right. So if we want to go ahead and name the triangle ABC, then the best way that we can go about doing that is starting, usually I start with the angles first, and then I go for the side lengths. So here we have angle A, we have angle B, and we have angle C. For the sides, we can state that AB is a side length, we can state that AC is a side length, and that BC is a side length. You'll also notice I'm actually using the naming convention, right? The segments. AB, AC, BC, they're segments. So I'm using the symbol and the notation, and I'm also using the angle symbol, which is this typically. Sometimes people will draw this as well when they describe an angle, like angle A. Just to let you know that, again, that's how we name them. Also, for the segments, you could also write it in the other order, right? You could have said BA, you could say CA, you could say CB, and those are equivalent. And with angles, there are other ways to name them too. For example, I could have named it as angle BAC or angle CAB or angle ABC or angle CBA, or I could do angle ACB or angle BCA. And that one requires using all three of them, but what I should point out is that the actual location of the angle is the middle letter, the middle vertice that we have there. That always reveals the actual angle that you are naming. So just keep in mind, I just flip-flopped the other two that I had here and here, right? And I still was able to name the angles, just like how I flip-flopped these two. So let's take a look at the word congruence. When you have the figure below, which are all those little flags there that have the exact same size and shape, similar to what you discussed in transformations with rigid motions, congruence means that you have figures that are not only going together, con meaning with or together, but they match exactly. They pair up exactly. They have the exact same shape and size, right? So remember that congruence is actually referring to equality in a sense, right? So congruence would mean that the length and angles have the same measure. In other words, the side lengths are all equal to each other, the angles are all equal to each other. That's what congruence actually means. So, congruent triangles, specifically triangles. To the right, you see two triangles that are labeled with hash marks or tick marks, or just marks if you want to call them that, along with the arc marks, right? So, when you have the side lengths marked the way that they are, for example, AB has two of these and XY has two of these, that means that they're corresponding sides that are also going to be congruent. And I know that XY also corresponds with AB because of a really important statement. This right here is what we refer to as a congruence statement. And a congruent statement is very important because you can see from the diagram certainly and through those symbols which segments are congruent to each other, right? The same number of segments for segments that match, that's what that indicates, meaning that they have the same length. And if you have an angle with the same number of arcs, which is again what this symbol is right here, then that means those angles are going to be congruent. But the congruent statement also can tell you that too, because the order matters, right? So you want to be very careful here. Order matters when you're looking at a congruence statement. For example, if you look at AB, the segment AB on the congruent statement are the first two letters of that statement, and XY for that triangle are its first two letters. So AB matches up with XY. Also, the angle A and the angle X are the first letters respectively in the figure, in the congruent statement. And so they happen to be congruent to each other, as you can see both from the diagram to the right as well as on the congruent statement and these congruent statements below as well. So we've got A congruent to X, B to Y, C to Z, and then the other segments as well. You want to be able to take a congruent statement as well as a diagram, and you want to be able to write out what are all the congruent pieces. And the reason we want to do that is because we ultimately want to prove that triangles are in fact congruent. We want to make justifications for that. So just please be aware that the order does matter when you write a congruent statement, and we use this type of notation to represent when corresponding parts of the triangle are actually congruent to each other. And with that being said, let's take a look at a practice problem. So here I want to identify the sides that are congruent, which means the sides that have the same length. AB and AC both have the exact same length. So we know that the segment AB and the segment AC are congruent to each other. And that is because they both have a length of 5. So that is me having identified which sides are actually congruent to each other. So take a look at this example, pause the video, and try this for yourself. Figure out which angles are actually congruent to each other in the triangle that you see there to the left. So you should have said angles B and C, right? So angles B and C are going to be congruent to each other. Now, the reason they're congruent is because they both have 50-degree angles and they're equal. And so as a result, we've identified which angles happen to be congruent to each other. So we looked at an example of sides and angles. So now let's go ahead and look at some vocabulary involving the word included. We have two different diagrams to look at. So let's focus first on the segments. So when you have an included side that lies between two specified angles, you can see in the triangle below there that the segment AC is the side included, and the angles are labeled with arc marks that we have. Those arcs don't necessarily have to have the same number. They can have a different number of arcs. What's important there is to recognize that the segment is between the two arcs, between the two angles, as you see visually right here. That's what it means to be an included side. However, I would also point out that you can tell that information if angle A and angle C are stated and provided to you and you're looking for the included side. It's just interesting to note that it happens to be the segment with the endpoints A and C, right? So if the angles A and C are what you're looking at and you're trying to identify what is in the included side between them, it's the endpoints for that segment that will be A and C in this case. So you can identify that right away just by observing the angles above. Now likewise, an included angle is going to have the same kind of rules in effect. So here you have two segments. We have A to B and we have A to C, and the angle in question is at angle A, and notice how it's between the two segments. So it is included because it's between them. And again, I would also point out, if you look at the two segments up there on the far right, you'll notice that both of the segments just so happen to share a vertex. That would be A, right? The endpoints of AC and AB, they both have an endpoint of A. So that reveals, because they both share the same endpoint, that the angle located at that exact vertex will in fact be the included angle that we need to have, right? Now that angle could also have been named angle BAC, or you could have named it angle CAB, but pay attention to the fact that the middle letter is still A, because that's where the vertex of the angle is located. That's what it means to be included for sides and for angles. So we need to be aware of this to properly identify the postulates or theorems of congruence for triangles. So let's go ahead and practice a problem where we're identifying those. Now I can identify them without even looking at the diagram because the statements alone provide me all the information I need. But it is important to recognize from the diagram what it looks like. So let's start by highlighting some things. Let's look at the segment AB and the segment BC in green. And then we'll go ahead and I'll look at AC in orange and BC in orange. So let's start with the green first, right? The angle between the green segments was here, and that is clearly angle B. You will notice, however, that that is also the one endpoint that both segments have in common. So that tells you angle B has to be that angle. So knowing that, look at the two segments here. They both have endpoint C in common. So that tells you automatically that angle C is the included angle. But you can also see that right here as well. Angle C is actually right there, and it is between AC and BC. Now the other setup here that we have deals with the angles instead, right? So I'm going to go ahead and kind of erase this information here, kind of get rid of that. Okay, so BAC is this angle right here, and I know that because A is the middle letter, the middle vertex, and B is the middle vertex. That would be this angle right here. So I will point out that since those two angles are the ones those angles are referring to, A and B together form the segment which is the included side between the two angles. And you can see that both visually here on the diagram because the side length is between the two angles, but you also can see that A and B together form the endpoints of that particular segment. And so as a result, that has to be the included side. So I certainly could do that with this one right here with C and A. I know that CA is going to be the included side without really even having looked at the diagram. However, you still want to make a practice of doing that, and in this particular case we can go ahead and do that. So we have the angle BCA, which is this angle, and CAB, which is this angle. So the included side is going to be CA or AC. Again, it lies between the two angles, and you can see that. Okay, so that being said, you can either apply the shortcuts I have on the left there where I'm just looking at the diagram, looking at the structure of the way the statements are written, and I can identify from that, or you can also look at it visually as well. But here we have to go ahead and figure out what would be the included side or angles depending on what's given to us. So the first two are asking us to identify the included angles, and the last two the included sides. So very quickly here, on the diagram you have RP. Certainly you could go ahead and just compare visually, but if you go over here, I'm looking for an angle here, and I'm looking for an angle here. And what's really nice is that these both share P, right? So angle P has to be the included angle. These both share R, so that means that angle R has to be the included angle. If these are the two angles that we're looking at, then the included side has to be the segment RP or PR. Either of those is acceptable and correct. And again, for these, it would be PQ or QP. Again, either of those would be correct. And I'm getting that by forming those two together, right? So that's going to form a segment. That's going to form a segment. That's going to be the included side. And I can recognize that right away. So now we finally get to the postulates. Now, you'll see this slide again, but we're going to focus on these first three highlighted in the green box below. And while it is true that we know that congruent polygons corresponding parts also are congruent, and it's nice to know all that information, we really want to try to be efficient and concise about how do we know that two triangles are congruent. We don't want to have what we call extraneous information, extra information, right? We want to get to the point and get exactly what we need. So that's why we're going to be using these postulates today, because they allow us to do just that. We'll focus on the other two in the next lesson. So this slide is very important. It can be very helpful for any future SBW that you're working with. Anytime you're trying to describe or otherwise describe the meaning, rather, of one of these postulates or theorems, this is a great slide to look at because it describes exactly what they're saying. So if you look at side, 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 what I want you to pay attention to is that for the two triangles to be congruent, that is only going to be the case if all three corresponding sides are equal in their length. And you can see they've color-coded the sides. They've also put the hash marks respectively on both triangles. That shows the side, side, side. For this one, you have to have two corresponding sides and an included angle to be congruent. So that means you have two pairs of corresponding sides that are congruent and a single pair of included angles that happen to be congruent. That's side angle side. The last one, we sometimes refer to it as the right hypotenuse leg. Conventionally, sometimes we also refer to it as the hypotenuse leg. And in this particular case, we do that simply because it is a right triangle pair. It has to be right triangles, okay? It's very, very important you understand these are for right triangles only. Right triangles only. This only works for those. What are we looking for? Well, if they have a right angle, they have to have that, where there's a pair of hypotenuses and one pair of congruent legs, then the triangles are congruent to each other. So these are the three right now that we're going to refer to through these practice problems. So looking at a practice problem right here, I want to go ahead and identify which reason is the reason why the triangles are congruent. I'm going to start by identifying that there is a segment here that both of these share. And a lot of times when they share that, what we do is we mark that down and we can state that BC is congruent to itself. And the reason why it is because it's the same line segment. So of course it's going to have to be congruent to itself. They both share that common side. So now that they've done that, what you can do is you can identify a reason why these triangles could be congruent. What I like to do, and you don't have to do this, and your teacher may not do this either, but what I like to do is I like to identify the side length by writing the letter that it represents. Like this is a side length, this here is an angle, and this is a side length. This is a side length, this is an angle, and again, that other triangle also has that as a side length. So if you look at that, it actually spells out SAS. So that tells me that SAS is going to be the reason why the two triangles are congruent to each other. Now, remember what I said about congruent statements. The order matters. However, when you start off writing a congruent statement, when you write out the congruent statement, the first three letters of your triangle actually usually won't be as picky, because if you start off with ABC or ACB or BCA, doesn't matter. That, however, will determine the order of your second triangle. So, for example, I know that A matches up with D, right? That is a corresponding angle. So the first letter of my second triangle needs to be D. I also understand that for the other ones, B is going to match up with C. C is going to match up with B. So that is going to be my congruent statement in that particular case. Okay, so you just got to be really, really careful about how you write that. But at the end of the day, the order matters. So please, please, please. In fact, just remember, order matters. Order matters here. What angles correspond? A little tip, if it helps, you don't have to do this, but you could always try to draw the triangles out separated, right? They share the side, but what happens if you pull them apart from each other, separated them out, like I'm doing right now, and you can label them the same, and that's fine. And there's nothing wrong with that. And you know these angles correspond, you know those angles correspond, right here and here, and you know these angles correspond. So if it helps you to write it out, if it helps you even to identify the reason, right? So side, angle, side. See how the angle is included in between the two sides? That's how I know it's SAS. That's another way to visualize the problem when you're trying to solve or determine what's congruent to what. So I would pause the video momentarily and see if you can come up with the reason why they're congruent, and then also what is the congruent statement that you would write. So in this case, we should have said SSS. Notice how they share the side QP. So when they share QP as a segment, QP is congruent to itself, right? Because again, same line segment. It's the same line segment, so therefore they're congruent to each other. So that's the third side for both triangles. And if you see here, I can even label that. I've got side, 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 side. So that's why the triangles happen to be congruent. So for me, I'm going to go ahead and write the congruent statement. I'm going to start by saying triangle SPQ. That should have been congruent to triangle RPQ. Right? So that is an example of a congruence statement. Now, please understand that if I were to rearrange the order, let's say I called this one QPS, then this one would have to be QPR. You see how it switches? That's still technically right. As long as the order of the one matches with the order of the other, then it's still a correct congruence statement. So there can be essentially more than one answer when you're doing that, but you have to make sure that the corresponding parts match up. Take this one for example. Here's an example of a right triangle pair. So automatically you might be thinking hypotenuse leg, right? So in this case we have a hypotenuse here and a hypotenuse there. And then we have a leg and a leg. So how do you know it's a hypotenuse? Well, we should recognize that it's a hypotenuse because it's opposite the 90-degree angle, right? The 90-degree angle. And it's a right triangle because of that. So it's hypotenuse leg, hypotenuse leg. So that tells me the reason why they're congruent is because of HL. Sometimes you can say RHL if you want. So now that I know that, I can go ahead and identify triangle ABC. ABC matches with EDF. So that is going to be my congruent statement in that case. And if you rearrange the letters again, that's going to change how you might write your answer, but they still have to match up. Little tip for right triangles, I tend to make the right angle the actual vertex, or rather the middle letter, I should say. It should be in the middle. I typically do that with right triangles, and that can be helpful for you when you're writing your congruent statements out. So what I would do here is pause the video and see if you can come up with the correct response for this particular problem. Okay, so this one you should have said side angle side actually. I know that they are right triangles, and that's fine. However, we want to recognize that they both share this side. If they both share that side, that is a side that is that's congruent, and we can write that down, right? We can say, oh, that's the segment BD. That's congruent to itself. We know why it's congruent to itself. We know that it's the same line segment. And if it's the same line segment for both triangles, it has to be congruent. We actually have a fancy name for that. It's called the reflexive property of congruence. Okay, having said that, recognize it's the same segment for both triangles, both right triangles. So therefore, it has to be congruent to itself. And what that does is it creates this relationship. You have side, an angle in between, and a side, side, an angle in between, and a side. So SAS is going to be the easiest one to utilize here. It may not be the only one. There might be other ways to justify the others, but again, right away, this one does actually work. So again, if I call this, for example, I could call it triangle ABD is congruent to triangle CBD. That would be an acceptable congruent statement. Okay, and so for this one, we're going to go ahead and look at this example here. And right away, I can see that it shares a side with both triangles. That is just a side length, so that's going to be a third side. And I have side, 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 side. So I see that side, side, side is the congruence postulate that we would use. And if I want to identify what's congruent to what, I want to be very, very careful here. I'm going to say triangle CDA. Notice how I went from C to D and then to A. So notice how I traveled along the segment with 2 hash marks. I need to do the same thing for the other one, right? So if I write it in blue, I need to go this way. A, B, C. And that is a congruent statement for those particular triangles. So you can pause the video on this last question here and see if you can come up with the correct response to these 2 right triangles. So here you should have said hypotenuse leg, because here we have a leg and hypotenuse, and a hypotenuse and a leg. So they correspond and they're congruent and they're right triangles. So that particular theorem technically, but you can call it a postulate if you want, works. And so now we can go ahead and we can say that triangle ABC is congruent to ZXY. ZXY. And that is going to represent lesson 4.05 for our exit ticket for today.